Hello everyone, welcome to engineering study and today we are going to cover that is soil classification. First chapter that is index properties of soil that has finished. Okay, and this is the second chapter of soil mechanics, and those who have not covered my first chapter lectures, first go through that lectures, then come to this, that is soil classification. The classification of soil on the basis of its size. Okay, there are several techniques, that is particle size classification, flexural classification, highway research board classification, Indian standard classification, but we will cover in this lecture Indian standard soil classification. Okay, these techniques actually used in most of the laboratories, so we will cover this topic, that is Indian standard soil classification. Before of this, we have to learn about this graph. Okay, so write a note here, note, and then draw this graph. Okay, and look into this graph very carefully. That is, this is a sheet size. Okay, 2 micron, 20 micron, 75 micron, 1, 2, 4.75 and 10 millimeter. Okay, all of these things I have discussed in my previous lecture, that is particle size classification, that is lecture number 5. First go through that lecture and then come to this, you will understand it in very easier way. Okay, and this is the percentage of particle, 10%, 20%, 30%, 40% and go on. Okay, now if you plot the different size of the particle and with its percentage, then you will get different type of graph here. Okay, this is a logarithmic scale graph. I will discuss how to draw the graph in our laboratories. Okay, first learn this thing very carefully, that this is a different shape of particle with different percentage present here, and we have plot this graph. Now look into this. There is, in this range 2 micron to 20 micron, this graph shows that this percentage of particle are very much higher than 20 to 75 micron size. Okay, but here all type of particles, 75 to 10 micron, all size particles present. Here only one size particle present, that is between 2 by 2 millimeter to 4.75 millimeter. But here one type of particle missing, that's why a straight line has came. Okay, now write the note here, note, and you will understand about the significance of this graph. Okay, write a note here, that is, first write it down, that is well graded soil, well graded soil, well graded, well graded soil. That means if the soil has good representation of particle, it is well graded soil. Okay, next write it down, that poorly graded soil, poorly graded soil. If the soil has excess of some certain size of particle and deficiency of another size of particle, then it is called as poorly graded soil. Okay, next uniformly graded, uniformly graded soil. If the soil have only one size of particle, it is known as uniformly graded soil. And last, gap graded. If certain size of particle are missing from the soil, it is termed as gap graded. Okay, and after complete the note, now look into this graph. That means all size particles are present in that sample. Look into this graph. Different size of particle present. So that's why it is well graded soil. Okay. Now poorly graded soil. That means certain size of particle are much higher than the another size of particle. 2 micron to 20 micron size particles are much higher than 20 micron to 75 micron size. So that's why it is poorly graded soil. And now uniformly graded, that means only one type of size present in the sample. Look into this graph. Only same size particle present, that's why it is uniformly graded. And gas graded, that means one size of particle is missing from that graph, that's why it is gas graded soil. So complete the whole note, this is important. Okay, then come to this. Okay, now shape factor. This is another important term of soil classification system, that is shape factor. Two terms is there: coefficient of uniformity, that is C suffix U, coefficient of curvature C suffix C, that is D60 by D10 and D30 square by D60 into D10. And what is this D60 and D10? D60, D10, D30 means percentage 60% particle finer with in respect with a particular sieve. Okay, write a note here. D10, write the note here. D10 means it is the size of the sieve. It is the size of sieve, sieve in millimeter, from which 10% particle are finer. Okay, so if you understand D10, D60 and D30 are similar. Okay, size of the sieve from which 10% particle are finer, that means 10% particle will pass through that respective sieve. Okay, now look into this picture. You have taken a 100 gram sample and you have put the sieve in this order. Okay, 40 millimeter, 20 millimeter, 10 millimeter, 4.75 millimeter, 2 millimeter and 1 millimeter. Okay, and then you start sieving and 10 gram retained, 90 gram passed, and from this 90 gram 30 gram retained and 60 gram passed. That means 60% particle are finer in 20 micron sieve. That means D60 is 20 millimeter. 60% particle finer, that means 60% particle will pass through this sieve. Okay, and now 30 retained, 30 pass, that means 30% particle are finer for this sieve, 10 millimeter. That means D30 equals to 10 millimeter. Now 20 here retained and 10 passed, that means 10% particle are finer for 4.75 millimeter, that means D10 equals to 4.75 millimeter. Now I think this is clear. Okay, and now write this note also, that is the value of Cu and Cc and how we will distinguish the soil on the basis of its value Cu and Cc. Okay, Cu if equals to 1, then it will be uniformly graded soil. If Cu greater than 6, then well graded sand. Okay, if Cu greater than 4, that is well graded gravel. Okay, if Cc value lies between 1 to 3, that is well graded soil. If less than 1, greater than 3, it is poorly graded soil. Okay, now Indian soil classification, Indian standard soil classification. Okay, and we already know from our lecture 5, that is soil has coarse grained soil and fine grained soil. Coarse grained soil and fine grained soil. For coarse grained soil, this method is based upon particle size and its shape factor. Okay, and for fine grained soil, it is based upon particle size, plasticity index IP and compressibility. In this method, soil is broadly classified into two groups: coarse grained soil and fine grained soil. Okay, and now we know this chart from our lecture 5, that is particle size distribution. If we distinguish the particles on the basis of its size, then we came to know that from 80 mm to 4.75 mm it is gravel, from 4.75 to 75 micron it is sand, from this to this it is silt, and beyond this is clay. Okay, and gravel and sand combinedly called as coarse grained soil, silt and clay combinedly called as fine grained soil. Okay. Now coarse grained soil. Now see this chart. If more than 50% particle retained on 75 micron sheet. Look, 75 micron sheet. If this is a sheet, if more than 50% particle, 51% particle, this is 75 micron sheet and this is 2 micron sheet. 51% particle retained on 75 micron sheet and past 49% sheet, then it can be called as coarse grained soil. Okay, and now if more than, write the note here. Okay, if more than 50% soil retained on 4.75 millimeter sheet, then it is called as a gravel, otherwise it is a sand. Okay, write that line here. Okay, and now fineness modulus, as I have discussed earlier about this. Okay, fineness modulus means percentage of silt and clay present in the soil. Okay, and now classification of fine grained soil. Before learning this graph, write a definition here. Okay, I am telling this, write this down. Okay, from here, it is based on particle size, plasticity and compressibility. This fine grained soil is based upon particle size, plasticity index and compressibility. Okay, if the soil is termed as fine grained soil if more than 50% particle pass through 75 micron sheet. If more than 50% particle pass through 75 micron sheet, if this is 49% and it will be 51%, then that soil will be fine grained soil. Okay, if more than 50% soil pass through this sheet, 75 micron sheet, then it will be called as fine grained soil. Fine grained soil further classified as organic clay, organic silt. Okay, and now on the basis of its compressibility, we can divide fine grained soil into three groups. Number one, low compressibility, low compressibility, low compressibility. Number two, medium compressibility, and number three, high compressibility. Now when liquid limit less than 35%, it will be low compressibility. When liquid limit is in between 35% to 55%, then it will be medium compressibility. If liquid limit greater than 55%, it is 50%. If liquid limit greater than 50%, then it will be high compressible soil. Okay, write this 3 note, 3 point, then come to this graph. Understand this graph very carefully. This is a liquid limit, WL. What is liquid limit? Go through my lecture 6 and you will understand liquid limit, plastic limit, shrinkage limit. Okay, and now this is plasticity index, that is IP. Okay, and now liquid limit 8, 20, 35, 55 and 50, and this is plasticity index IP. And there is a line, that is A line, that starts from liquid limit 20 in this pattern, and value of this line and equation of this line is IP equals to 0.73 into WL minus 20. Okay, and the significance of this line is if plasticity falls below a line, then it will be sealed. Ml, Mi, Mh. M means silty soil. Okay, L means low compressibility, silty soil. Medium compressibility, silty soil. MH means high compressibility, silty soil. Okay, and if plasticity lies above a line, then it will be clayey soil. Cl, Ci, Ch. Low compressibility clay soil, medium compressibility clay soil, high compressibility clay soil. Okay, this line called as A line. Okay, and write this note very carefully. And here is a zone. Okay, that is 4% and 7%. If plasticity is below 4% and the point lies in this side of this line, then it will be also sealed. Okay, if above 7%, then it will be clay. And the intermediate zone between 4 to 7, there are two types of particle may present, that is sealed and clay. Write the whole graph, draw this whole graph very carefully. Okay. Now, classification of coarse grained soil. Classification of coarse grained soil on the basis of its fineness. If fineness less than 5%, if fineness 5 to 12%, if more than 12%. Okay. So, and now write this down, the notation how we will call if gravel in short term G, sand S, silt M, clay C, organic soil O, oil graded soil W, poorly graded soil P. Okay, write the note. And now if fineness less than 5%, if that means if percentage of clay and silt is less than 5%, that means very less amount of clay and silt present in the soil. So we can neglect the term silt and clay here. We can only distinguish the soil on the presence of its on the quantity of its gravel and sand. Okay. Now if percentage fineness less than 5%, then it will be gravel and sand, and oil graded gravel, poorly graded gravel, oil graded sand and poorly graded sand. And how we can define it as a oil graded and poorly graded, write that down. Here first point will be, as it is gravel is oil graded gravel, then gravel greater than sand. First point, gravel greater than sand. Write this here also, gravel greater than sand. Okay. The number 2 will be, and shape factor what we have learned, Cu d60 by d10. Okay. So if Cu greater than 4, what it will be, oil graded soil, oil graded gravel. Okay. And now if value of Cc lies between 1 to 3, we can also call this a oil graded gravel. And poorly graded means Cu, and this criteria does not match. Okay, Cu is not greater than 4, Cc is not between 1 to 3. Okay, then it will be a poorly graded gravel. Write the two note here. Okay, write this note here. And now oil graded sand. First, sand means quantity of sand is greater than gravel. First point. Okay, write these points below of this SW. Okay, and now number 2 will be oil graded sand, Cu value greater than 6. And now third Cc value lies between 1 to 3. Okay, and for this case this value range does not apply here, that's why it is poorly graded soil. Okay, now if percent fineness greater than 12%, greater than 12% means there are significant quantities of silt and clay present in the soil. Okay, so we can't ignore silt and clay here as we have ignored it here. Okay, because there are very less amount of silt and clay present, less than 5%, but here greater than 12%. So we have to consider the quantities of silt and clay. Okay, so and now how we can call it as a GM means silty gravel. Okay, write the note here also. GM means silty gravel. Okay, silt term will come first and then gravel. Silty gravel, clayey gravel, silty sand, clayey sand. Okay, and now gravel means quantity of gravel greater than sand, first point. And second point, silt means quantity of silt greater than clay, second point. Third point is as it is a silty soil, and from the previous graph what we have learned, in this graph what we have learned, below this line it is silt and above this line it is clay. Okay, so IP value below A line. Okay, that's why it is silt. And okay, so these 3 points is important. And now for clay, gravel greater than sand, clay greater than silt, second point, and as it is clay, IP value lies above A line. Okay, and GMBC means both type of silt and clay present. Okay, a single point. So write this down: sand greater than gravel, silt greater than clay, and it is silt is lies between below A line. Okay, write this down by your own. Okay, these points. And now, if percent fineness is lies between 5 to 12%. Okay, that means there is not significant amount present but sufficient amount present that we can't ignore the presence of silt and clay. Okay, so we have to denote it here as GWGM. That means W means oil graded gravel, and silty gravel. Oil graded silty gravel. Okay, this is oil graded clayey gravel, and this is poorly graded silty gravel. Okay, and now the criteria to be oil graded we have already write it here. So all these criteria have to fulfill for oil grade soil, and all these criteria have to fulfill for silty gravel. Okay, these 6 criteria should be fulfilled, then we can call it as a oil graded silty gravel. Same for this, these 6 criteria should be fulfilled, so that's why it is oil grade clay gravel. And write the whole part by your own. Okay, and I will discuss this in the next as you have write it properly or not. Okay, so thank you for today. This is the end of second chapter of soil mechanics, that is Indian standard soil classification. Okay.